Can ChatGPT technology actually simulate a quantum system? Microsoft Copilot for Azure Quantum. Is this a need? How is nobody talking about the fact that Microsoft just plugged in OpenAI's GPT series artificial intelligence into their quantum computing project? There is a quantum code editor that you can use, which I'm going to use in this video right now, with artificial intelligence to help you write that quantum code, which can run on a real quantum computer. And I feel like this news really irked the guys over at Google Quantum. Like, kind of like poking the bear. I think just like out of anger, they just decided to drop their 70 qubit quantum computer on the world, which is 241 million times more powerful than their 2019 quantum computer. What? And that straight up stomps on IBM, NASA, D-Wave, IonQ, and Microsoft's best quantum accomplishments. Google just reminded all the other players to know their role. Let's start with Microsoft Copilot for Azure Quantum. So even if you weren't surprised by how quickly GPT technology made it into all of Microsoft's products, this one might still take you by surprise. Honestly, it caught me completely off guard. It never showed up in a news aggregator. I haven't heard any of the other YouTubers talking about this, but it's definitely a thing. This is Microsoft's official blog. And you can see right here, you can try Copilot in Azure Quantum right now, which means that we have an AI-based assistant, a ChatGPT for better or worse, that can actually help us with quantum computation problems. And they outline 4 main things that a quantum Copilot can help you with: learning about quantum computation and computational chemistry, writing quantum code, running a quantum simulation, and visualizing quantum data. Quantum mechanics, the quantum world doesn't follow classical rules, so this is going to be interesting. All right, now let's talk about quantum code, something I know nothing about, but let's learn together. So Azure Quantum gives me an online IDE to actually write some code. Okay, so it looks like it wants us to write in Q#. I don't even know what that means. So Generative Google says Q# is an open source high-level programming language for developing and running quantum algorithms. All right, well, let's lean on GPT because I don't even know where to start. Write me an interesting but simple Q# program that I can run right now to get a sense for how it works. Here is a simple Q# program that demonstrates the behavior of a single qubit in superposition. It prepares a qubit in a superposition state, measures it, and prints the measurement results. Oh, cool. So cool. Okay, allocate a qubit. What is a Hadamard gate? Fundamental quantum gate. Okay, I guess like a logic gate, but with more probabilistic tendencies. A Hadamard gate creates a superposition of states. It's critical in many quantum algorithms because it allows us to exploit quantum parallelism, which is one of the key advantages to quantum computing. Okay, so then we measure the qubit and we print the measurement. Okay, copy to the code editor. Wish me luck, it's runtime. Scroll down to see the results. Quantum algorithm results are probabilistic and thus displayed in a histogram. Okay. Oh, 30 and 70%. So did we make a qubit and then it collapses into 70% of the time the 0 and 30% of the time the 1? I don't know, a lot to learn here, but that's the TLDR. GPT-4 is plugged into this quantum computation stuff and who knows where that's gonna go to. Smash that subscribe button. So this is Microsoft's Azure Quantum, their cloud system for working with quantum computation. So learn more about how Copilot is built into the Azure Quantum elements now in private preview. Boost your research and development productivity with simulation workflows optimized for scaling in the Azure High Performance Computing, HPC clusters, AI accelerated computing, augmented reasoning using artificial intelligence, integration with quantum tools to start experimenting with existing quantum hardware, and access in the future to Microsoft's quantum supercomputer. So welcome to Copilot in Azure Quantum, here to assist you in your chemistry journey. Cool, let's do it. Okay, so this is the beta carotene molecule, the orange pigment that we see in carrots. Now, I guess accurately modeling these molecular orbitals is challenging for classical computers due to the size and complexity of the molecule, but it's the kind of thing a quantum computer can do really well. Let's just go ahead and see the atoms here because that makes a little more sense to me. What is ATP? Can you visualize the molecule? Okay, here's some information about ATP. Looks like it generated the molecule for us, probably using DALL-E or something in the background. Oh, or maybe it's not two-dimensional. Let's check it out. Oh my God, that's what powers us all? That's ATP? Dude, all I remember about ATP is I think you break that little piece off and this becomes energy and this gets recycled maybe? I don't know. What part of this molecule breaks off when it turns into energy? Okay, one of the phosphate groups breaks off. So I think this part breaks off. What is a phosphate group? can you visualize the molecule for me? Oh, I can visualize the structure of ATP, which contains 3 phosphate groups. Here's a visualization. Like, speaking from a novice point of view, maybe if you're really a chemist and you think about how these things may or may not come together, you could ask it, like, is it probable that these two orientations of atoms would actually like connect, or would they break apart? And then maybe the AI starts getting trained on that, and this is the beginning of that story. Google has developed a new quantum computer establishing their quantum supremacy. In their newly published paper, Phase Transition and Random Circuit Sampling, they showed off a new, more powerful device. And this next-gen quantum computer boasts 70 qubits. That compares to the 53 qubit predecessor from 2019. But remember, the addition of qubits exponentially bolsters the computational power, meaning that the new machine is a whopping 241 million times more powerful. So yeah, and to put that into perspective, for certain types of quantum calculations, like predicting the weather, simulating chemistry, it would take the world's supercomputer right now, a classical, 47 years to process 7 seconds of what this can do. So did we make a qubit and then it collapses into 70% of the time the 0 and 30% of the time the 1? And this is because they've come up with a breakthrough in the way that they can manage the noise problem. Basically, these qubits, obviously our environment wants them to find a state, they want them to decohere. It is very hard to keep them in quantum positions, but they've managed to do it, at least for these 70 qubits. So right now, Microsoft's actual quantum computer just isn't quite where Google and some of the other ones are, but they have laid out a plan so in the long run, they can maybe take that crown. So they presented a roadmap to being the top quantum computer in less than a decade. And the plan is to use something called topological qubits to achieve 1 million reliable quantum operations per second. And this marks a significant step forward because it's a different paradigm from what we have now, which is called a intermediate scale quantum computer. Now, this plan is coming off some success Microsoft had with a previous project called Majorna-based qubits. Now, the next process they need to do in the real world is entangle these qubits and then operate on top of them through a new process called braiding, which is a theoretical process that's been around since the early 2000s, but the math checks out, and when they build this thing in real life, they think it's going to work. So it's a bold plan, but only time will tell, and right now Google sits on that throne. What does it mean to say I want to build a topological quantum computer? How is that different? So a topological qubit, which is also known as an anion, and they represent an alternative to the more standard physical qubits we have now. And although not like normal because it's still quantum, they are physically representing spin and charge. But the topological part means that you braid these things together and then you think about it almost like a surface where you measure across the surface. Stretching, bending, continuous deformations. That's how they're actually going to do the computing. And it's interesting because if this works, topological quantum computers actually keep the data at a higher level. It's a global property of the braided anions. And it really is like a sheet because anions actually only exist in 2 dimensions. They don't even make 3-dimensional anions. So think about that for a second. This doesn't have a 3rd dimension, which I know is like really weird to say, so I can't imagine as anything other than like a sheet of paper. But the advantage is the sheet basically stays the same even if certain individual qubits decohere, so it's sort of resistant from errors in that way. So maybe they can get away with having a less sophisticated computer as Google does in the sense of each individual bit, but overall still get more information out of the computation. So get ready for a quantum future. And look, this is one of the topics where we have to throw IBM into the conversation also, because they're trying to build a 100,000 qubit quantum computer. Remember, we were talking about Google breaking records with only 70 qubits? Well, IBM made an announcement at the G7 summit in Hiroshima, Japan, that the company's partnering with a couple of universities, Tokyo and Chicago, and they've got $100 million to start tackling this. Now, the idea is that this 100,000 qubit system will actually plug into a regular classical supercomputer, and the way the algorithms will run will actually utilize both systems. Now, the first goals are drug discovery, fertilizer production, and battery performance, but more are going to come after. And it's technically called quantum-centric computing because it's a mix, which positions them in a different way than the topological qubits that Microsoft's working on, and the top-tier, super-cooled actual qubits that Google is rocking with right now. So the quantum race is on, and maybe, unlike in a classical race, there could be multiple winners in superposition? That's stupid. That's stupid. Smash that subscribe button.